Hey there! Ready to dive into a nifty piece of Python code? It's about sniffing out a row with, let's say, a maximum 1 among others using nothing but Python's standard library. Now, why would someone need to find a row with max 1 though, you ask? I'm glad you asked. Think about data analysis or any situation where spotting anomalies or specific patterns is essential. Let's say you have a bunch of rows representing sales data from different branches of your company, and you want to quickly identify the branch with, hypothetically, the minimum sales. That's your row with a max 1, the sole one indicating the smallest sales figure amongst the dataset. Sound useful? Now, on to the Python code. Imagine you have your data in a CSV file named sales.csv. The first step involves reading the file. But since life tends to be messy, we'll handle exceptions where the file might not exist. So, wrap your functions with a try-except block, safety first. The next trick is using Python's built-in CSV module to read the file. It's as delightfully simple as using the dict reader. We define max_sales is equal to 1 as a starting point just in case we are looking for the minimum sales value after all. As the code iterates through each row, think of each as a branch here. We check the sales for this maximum 1 by comparing it to the max_sales we initialized as -infinity. Python import CSV try with open as sales_file, sales_reader is equal to csv.dictReader max_sales is equal to float for row in sales_reader, current_sale is equal to float if current_sale max_sales, max_sales is equal to current_sale except file not found error. Print. This snippet opens the CSV file and initializes max_sales with the lowest possible value, allowing any valid sales figure to be considered as the new maximum. It then reads each row of sales.csv, converting the sale figure into a float, and updates max_sales accordingly. After establishing the maximum sales value found, we need to hunt down which row or branch yielded this figure. We start with the first row, comparing the sale to max_sales. If there's a match, the branch details are printed, and our Python quest comes to a triumphant end. Python for sale_entry in sales_reader. Cur_sale is equal to float if cur_sale is equal to max_sales. Print break. Now, to spice things up, let's handle exceptions when the file might not contain the column sale. Again, safety harnesses, Python's try-except, come into play. Python try for sale_entry in sales_reader. Cur_sale is equal to float hash rest of the code except key error. Print except value error, print except exception as E. Print. Now let's assume you fancy using pandas, a Python library, making things even more slicker like a hot knife through butter, or in our case, slicing through rows like a whetstone on a blade. Python import pandas as pd_try. df is equal to pd.re add_csv max_sales is equal to df.min max_row is equal to df is equal to max_sales dot ilog. Print except file not found error, print except key error, print except value error as way, print except exception as e. Print. In both snippets, we gracefully handle file not found error, a value error. And let's not forget about the generic exception, because even a cat is better prepared with a belly slide case cover, right? This Python journey, from opening files to handling exceptions, is about making the code resilient and robust against real-life imperfections. Keeping the code as readable and straightforward as the words here, you've got yourself a neat little toolkit to find the row with max 1 in no time. And there you have it, a guide packed with practical Python tricks ready to hunt down any row with max 1 with ease. Did I paint a comprehensive picture? If you are up for more, check out Neeraj's channel and subscribe. Till next time to TechLab, stay curious, keep coding, and may your data always be insightful. Check me out at Neeraj's channel and subscribe to TechLab.